Hello students, today we're going to work on the paper that I gave you called Simplifying Square Roots. There's a word problem that takes up about half of the paper, but I want you to look down at the part that says directions. Let's read the directions together. Simplify each expression. Express your answers in radical form and as a decimal rounded to the nearest tenth. Then answer the questions on the next page. We're going to work on a few examples to get you started with this. Number 1 is the square root of 24. Remember, we want to simplify the square roots so that there are no perfect squares in the radicand. So the first thing we have to recall is, what are the perfect squares? What I've done is I've written the first 10 perfect squares to the right of the page. We know there's an infinite number more. But when we think about the number 24 and we think about the factors of 24, we want to think about all the factors of 24, and are there any factors of 24 that are perfect squares? Well, I'll just jot down some factors of 24. You have 2 times 12, you have 3 times 8, you have 4 times 6. Okay, that of course doesn't include 1 times 24. Of the factors 2, 12, 3, 8, 4, and 6, which one is a perfect square? Which, if you look over to the perfect squares to the right side, you see that 4 is a perfect square. So we're going to rewrite the square root of 24 as the square root of 4 times the square root of 6. And you know that we start out writing it this way, and then we separate the factors into two separate radicals. Now, because 4 is a perfect square, we can simplify the square root of 4 to be 2. And we look at the times the square root of 6 and realize that 6 is not a perfect square, so it cannot be simplified. So it stays in radical form, and this is the exact form of a number rather than finding the decimal approximation. Well, your worksheet also asks you to find the decimal approximation. If you punch 2 times the square root of 6 into your calculator, or the square root of 24 because they are equal, you will get a long decimal that looks something like this. What the directions tell you to do is then round that to the nearest tenth place. So we have to underline the tenth place and then look at the number next door. And since it's a 9, we round the 8 up to a 9, and the decimal approximation is 4.9. Let's do the same thing for the square root of 48. Let's think of all the factors of 48, and can we find factors that are perfect square? Well, we have 2 times 24. We have 3. If you divide 48 divided by 3, you'll get 16. So 3 times 16. We have 4. If you divide 48 divided by 4, you'll get 12. So these are the factors of 48. Which one or two of them are perfect squares? Well, if you said that 4 is a perfect square, you're right. But guess what? 16 is also a perfect square. So what we want to do is we want to use the largest perfect square possible. So we're going to use this factor pair, 16 times 3. So the square root of 48 is equal to the square root of 16 times 3, which is also equal to the square root of 16 times the square root of 3. Now, of course, we can simplify the square root of 16 to be the square root of 16 is 4. And the square root of 3 cannot be simplified, so our answer is 4 times the square root of 3. And if we punch that into our calculator, we should get 6 point something with a very, very long decimal, and when you round it, it rounds off to 6.9. Do this process for all of the numbers 1 through 16 on the worksheet that I gave you. Ask questions or write questions down on your Cornell notes for when you come to teacher.